A very good morning, Ashilo. Am I audible to you, Ashilo? Okay, good. So just we are starting session because yesterday we discussed some numerical problem on distance system. I have discussed about feeding from one end, feeding from both end. We have discussed. So today I'll discuss about the numerical problem because yesterday we have discussed about the theoretical portions, that how can you find the voltage drop in distribution system, either it is DC or it is AC. Okay. So starting the lecture now. Okay. So look, can you see the screen? Can you see the numerical? Are you able to see the screen? Okay, good, good. So I will explain one numerical, okay? And also I'll give you one numerical to solve to you. You have to reply the answers and the value in the chat box. Okay, yeah, great. So you can see the numerical that already in numerical they have given that a 2-wire DC distributor AB having a length of 300 meter long, it is fed at point A. So you can see if I'm giving a feeding point 1, that is called feeding point at A, it means we are solving a numerical problem on DC distribution first of all and feeding from one end. So first of all, whenever the questions are happening in the exam, you must find then which type of distribution is given. First of all, it is one-sided, it is both-sided. Clear, that you have to confirm. Second, it is DC or it is AC, that you have to find. So here we are talking about DC distribution system, and this terminate. Okay, so you can see, because this type of numerical you have already solved in 5th semester, that is APS 1, clear. And also I've discussed the same thing yesterday in the yesterday lectures we have discussed. Now that we have to keep in mind whenever we are talking about such numerical, we have to find that at which point we are getting the power, clear. So first of all, we have to make a single line diagram. You can see very well the distance that is given 300-meter long. So first I'm drawing a single line and feeding at point A. Keep in mind this diagram you have to draw, that is called A point. Clear? I am feeding at A point here. Now the points that is given, you can see C, D, E, F, the points is given. So this is called A, second point is called B, and AB that is called 300-meter long. You can see AB that is called 300-meter long. I'm taking that C, point C is there, point D is also here, and that's I'm taking E, and I'm taking that is your F point. Clear? So these are the consumer points. You can see I'm taking here C, D, E, F. Clear? Now distance, you can see distance are given A, distance from A in meters. So of course C point is far away at 40 meter from A, and you can see D is 100 meter. Clear? D is 100 meter far from A. So of course if this is 100, then 100 minus 40 will be 60 meter. Means distance between C and D will be 60 meter. And E is 150 meter far from A. So already we have taken 40 plus 60, 100. So 150 minus 100, that is 50 meter. So we are finding the section distance first of all. And 250, so of course that will be 100 meters. So Ashley and Meherat, are you getting my point? How we are finding the section distance? Clear? So now you can see 40, 60, that is 100 plus 50, 150 plus 100, 250, and the remaining that is called 50 meter. But here this no load connected, or we can say no section or no terminal is given. Clear? Now if I'm finding the current, clear? So how can you find the current? So you can see that concentrated load in ampere, that 30, 40, 100 and 50, here that is given already. And they have given that if the maximum percent voltage drop is not exceed 10 volt, find the cross-sectional area of the distributor. That we have to find. Clear? So we have to find area first of all. Now before that we have to find, so first of all we have to find current. Clear? So how can you find anyone? And means Merit and both of you. Anyone, can you reply? You can see they have given rho, that is called resistivity. They have given 1.78 into 10 to the power minus 8 ohm meter. They have given already. Already I have said number one, when we are solving this numerical, number one, find the distance of each section. Number two, find current of each section. Number three, find voltage drop at each section. That is called I into R basically. Clear? And number four, that is called voltage at each point. That to find means in this circuit DC voltage at C, DD voltage at D, VE voltage at E, and similarly voltage at F point B, F you to find. Clear? So how can you find the resistance? We know that is called resistance equal to rho L by A. Clear? But keep in mind here that A that we have to find actually. Clear? A that we have to find. Clear? Voltage drop they have given, current they have given, resistance they have given. So we have to find the resistance in terms of A first of all, then multiply I into R and the voltage drop. Now first of all, we'll find voltage drop of each section. Means first I will find VAC. What is the VAC? voltage drop across AC section. Then BCD, that is called voltage drop at CD section. Then VDE, voltage drop at DE section, and voltage drop in EF section. And next one, voltage drop in FB section. But in FB section, voltage drop will be 0 because the current will be 0 here. That's now the thing is that they have given that the total voltage drop must be less than or equal to 10. Clear? So from this problem, already the given data we are applying here. So ultimately we are finding that BAC plus BCD plus BDE plus BEF must be equal to 10 volt. Clear? First of all, that is given. Equation number 1 we can apply from here. BAC plus BCD plus BDE plus BEF equal to 10 volt. Now what is the VAC? That is called resistance of this section RAC into IAC. Clear? Now you can see they have given the current that 30 ampere. At C point they have given 30 ampere, 40 ampere, okay, and E, that is called 100 ampere, and that is called 50 ampere at that point. Already I have said whenever we are finding current of this section, of course this will be 50 ampere. Clear? It will be 100 plus 150, so that will be 150 ampere. It will be 150 plus 40. I'm simply applying KCL, that is called 190 ampere, and it will be 220 ampere. Clear? So Asla, are you getting my point? How can we solve this numerical? Okay, done. So now I'm going for the solution. So have you got the steps that how will you solve? How will you solve? First of all, I'm finding resistance in terms of A with the help of the length that is given in meter. Clear? And I'll find the rho that already have given in meter or rho meter also. Clear? So area will be also in meter square. I'm assuming that area will be meter square. I will convert in mm square later. So find the distance in terms of A. Already current is given. Then find I into R of each section. Then find voltage drop of each section by multiplying by resistance and current of that section. Then add all voltage drop and must be equal to 10 volt. Yeah, Ohm's law, that's I'm applying here. Perfect. Clear? So just I'm solving this numerical. Okay. So anyone, just give me your answer. Have you solved this numerical? Please try it. Then I'll go for the second numerical. No. Actually, no. I'm not applying resistance for Ohm's law. I'm applying resistance. I'm just erasing. Don't worry. Just I'm doing it again. I'm applying that. Just I'm drawing this one here. Don't worry. First of all, that you got. What is the numerical is saying something? Have you got the perfect diagram for that one? Have you got the current? How we are finding the current that you have found? That what is the 50 ampere, 150 ampere, 200 that you have found? Am I right? How can you find RAC? Okay. How do you find RAC? First of all, RAC that is equal to rho, that is called 1.78 into 10 to the power minus 8 into what distance you can see? 40 meter. So into 40 divide by A. Clear? It's your RAC. What is the IAC? IAC equal to, already I said, what is the IAC? IAC equal to 220 ampere. Then what is the VAC? VAC equal to IAC into RAC. Have you got my point? Clear? Similarly, if I'll find for RCD, second one, clear? If I'm finding RCD at that time, if I'm finding this one RCD, so what is RCD? I'm changing only this distance. I have to take here only 60. Clear? And current we have to take, that is called 190 ampere. So every time you can see this is the value that is constant. Are you getting my point? So this time I'm sharing my whiteboard, don't worry. Suppose I'm just writing here 1.78 into 10 to power minus 8. That is constant rho. Clear? Divide by A, that is also constant. What I'm changing that is called RAC into IAC. So that already I'm taking distance. For distance, first one. Distance that is called 40 meter. Clear? 40 into 220. Clear? 40 into 220 that I'm taking here. So this will be your 40 into 220. Similarly, plus next distance that is 60 into 190 plus similarly for third section, for fourth section must be equal to 10. Okay, must be equal to 10. So this equation you have to solve actually. Just solve this equation and find A, that is called area in meter square. Clear? Asla, are you getting my point? Okay, done. So this was the solution of your first one. Clear? Second numerical I'm solving now. So this was the first one. In second one, you can see the second numerical we have given. Second numerical that a 2-wire DC statements AB 600 meter long is fed from both ends at 220 volt. Now, the first numerical that I've done for feeding at one end, second numerical I'm solving for from both ends. So now what's changing here? In this numerical, I'm changing this one. It's your A point and that's a B point. Clear? At A point, I'm taking, you can see feeding from both end at 220 volts. So that's very good that both end A and B, I'm providing similar voltage, 220 volt, 220 volt. That's point A, that's point B, and AB that is called 600 meter long. Clear? Now loads of 20 ampere, 40 ampere, 50 ampere, 30 ampere are tapped at a distance of 100 meter to 50 meter, 400 meter, and 500 meter from at end A. So we are tapping here, that is called 20 ampere. 20 ampere. Next, that is called 40 ampere. Then 50 ampere. And that is called 30 ampere. Clear? Now distance they are giving from the far end A. So of course we have to keep in mind that if this is 100 meter, next will be 250 minus 100, 250 minus 100, that will be only 150 meter. Next 400 minus 250, again 150 meter. And 500 minus 400, that is called again 100 meters. So what's the remaining? That is 100 meter is remaining. So you can see 100 plus 100, 200, and 300 plus 100, that total length will be 600. So this will be your single line diagram of this system. Clear? Now what they are asking, if the area of cross section distributor conductor is 1 centimeter square, they have given that A area equal to 1 cm square, and rho also you can see rho is given in ohm centimeter. So keep in mind, already I've discussed before that, if rho R equal to rho L by A, if your rho is coming, so rho equal to R into A by L, Clear? So rho is coming only and only ohm centimeter. It means that area is also in centimeter square and length we have to take in centimeter. Clear? So keep in mind this thing perfectly. When you're finding R, at that time we are using the formula rho L by A. So for example, if I'm finding for this section, that is called point C, D, E, and F. If I am finding the distance for RAC, clear? If I'm finding resistance for RAC, so ultimately what's going on? So what is the rho? That is called 1.76 into 10 to power minus 6. What is the distance you can see? 100 meter. This is 100 meter for AC section. So first we have to convert 100 meter into centimeter, divide by 1. Why 1? Because 1 cm square, they have given the cross section area. Clear? Find the minimum consumer voltage. So they are finding the minimum consumer voltage, or we can say potential at minimum point. Clear? Point of at minimum potential. They have to find, in this numerical, we have to find potential at, okay, point at minimum potential we have to find. So now if we are, so hopefully you are capable to find RAC. Are you getting my point? What we are doing here? So it will be 10 to power 4. So 1.76 into 10 to power minus 2. So answer will be 0.00176 ohm. That's the resistance of 100 meters. Similarly, I'll find for 150 meters. Similarly, next are AC, RCD, RD, REF, and RFB. That we have to find. Yes or no? Yes, row? Okay. So just I'm showing the solution, not all of you. Okay. So first, this diagram already have given to all of you. You can see clear. I've just assumed this one. Suppose you are taking IA from this side. If you are flowing the current from this side, then the current will be minus from that side. If you are assuming current from this side, it will be positive. So suppose I'm taking IA. So according to KCL, if 20 ampere is tapped here, so of course the further current will be IA minus 20. Now, if 40 ampere is tapped here, so further will be IA minus 60, because the simple funda I'm applying here. Suppose I'm giving I1 current from this line, and if I'm giving I2 at this tapping point, what is the current further is going? That is called I1 minus I2. Simple KCL I'm applying here. Clear? So on simple basic KCL I'm applying here, and just I'm finding the current of each section that we have found: IA, IA minus 20, IA minus 60, IA minus 40. Clear? Why we are finding like that? Because now you can see I'm talking about the voltage feeding at both ends. If you are feeding voltage at only one end, so of course at that time there is no need of like that minus like that, because we can add something. Because if there is only one end, so means there is no voltage, so current will be 0. So now this is 30 ampere. So in this branch, only 30 ampere will go, because in this branch current will be 0. Clear? Now, if 30 ampere will be here, this is 50 ampere, so it will be 80 ampere. So that from one end, it is very, very easy to find out current, but here we have to find. Now, one more thing, if both potentials are equal, no problem is that, but ultimately both potentials are different. Now tell me, if I'm saying BA equal to 220 volt, and if BB equal to 250 volt, which direction of current should I consider? Whatever I've considered now, it is okay. If I'm taking 220 volt at A point, 250 volt at B point. Perfect. We have to reverse, because the current will flowing from the high potential to lower potential. So now we have to start from here. That suppose I'm saying from here, that will be IA. Now, if this will be IA minus 30, it will be IA minus 80, IA minus 120, IA minus 140. So the current will be reversed. Clear? Good, good. So that's a good thing. Okay. So first of all, whenever the questions is appearing in the exam, first of all, you have to make this diagram. This diagram is very compulsory part, because Without this diagram, you can't solve this numerical. So next one, first of all, we are finding the resistance. Already I have said, first of all, we have to find the resistance. Now, resistance of 1 meter length, if you're finding for 1 meter length, we are giving 2 cross. Why? Because you can see the diagram, you can see the numerical, a 2-wire DC system is there. Clear? So first of all, we are finding resistance of 1 meter. So already I have said, because it's your 1 centimeter square area that is given. So I'm converting 1 meter into centimeter. So of course 1 into 100. Clear? So, and that is already given rho. I'm giving multiply of 2 because I'm talking about the 2 feet, 2-wire system. So what is the resistance of 1 meter? 3.4 into 10 to minus 4. Now we know the distance. Already I have said. For AC, this is 100 meter. For CD, 150. For D, 150. For EF, 100. And for FB, it's again 100 meter. So we are finding the resistance of each section. Clear to everyone now? Absolutely, it is clear. Or there is any question that why we are multiplying by 2, why it is 100? Is there any question? Then you can ask. Else I will move further. Okay, done. Good. So now already I've said, whenever we are solving such numerical, we have to find number 1, we have to find the distance of each section. So part number 1 have completed, you can see. In second part, we have to find current of each section. So already we have applied KCL. Have you seen? Clear. Now after finding, first I found, you can see first I found the current of each section with the given equation. Second, we have found voltage, the resistance of the each section. Now third, we are finding voltage drop of each section. Clear. Now you can see what they are doing. Actually, what is the voltage at B point? I'm giving you an answer. Suppose I am saying this is the line. For example, this is the line. And at this point, I'm saying the voltage will be BV. And I am feeding here BA voltage. And here some drops are there. I1, R1 in section number 1. In section number 2, I2, R2. In section number 3, I3, R3. In section number 4, I4, R4. So what is the voltage at B point? It's very easy to understand. That is called simple potential difference rule, that VB voltage at this point will be equal to sending end voltage minus all voltage drop. Clear? So that's, you can see I'm doing this one. Are you getting my point? That's slow. So what we are doing here, ultimately what we are finding BB and we are applying the all equations. So of course 220 will be 220 will be 0. Clear, minus and will reverse. So ultimately we are finding the solving equations. RAC we have already found. IA minus 20, that is the current of CD branch. IA minus 60, that is the current of D branch. Already I have said. IA minus 110, the current of EF branch, and IA minus 140 current of the last, that is called FB branch. Clear. So first of all, I have, because now you can see in the first one portion already I have assumed the current. So you can see we have assumed the current in terms of unknown quantity, because IA minus 20, IA minus 60, IA minus 110, IA minus 140. So already what we have done, we have assumed current as per requirement. Then we have made the equations of potential difference, PA minus P equal to I into R. Clear, total potential drop. After that, what we are doing, after applying the simple potential difference equation, that is called BA minus VB equal to I into R, or we can say potential difference of both point BA minus VB equal to total potential voltage drop across all sections. So when I have found the equations and I have applied the equations, I have found IA. That is called IA, means that we can say current at starting point IA from A to C. So after IA finding, we can find all currents. Clear? Now we are finding minimum consumer voltage. So first of all, how can you find minimum consumer voltage? I'm just explaining here. You can see that what is the value of IA? 61.7 ampere. Yes or no? Absolutely, yes or no? We have solved the numerical. What is the IA? 61.7 ampere. Now, if I'm applying IA value in all parameters, that I'm getting only 41.7. Clear? And in this section, I'm getting only 1.7 ampere. Now you can see when I'm going 61.7 minus 110, clear. So we are getting the current, clear, we are getting the current in reverse condition. 61.7 minus 110, if I'm applying, we are getting minus 48.3 ampere. So actually the direction, assumed direction will be like that. I have assumed that current is flowing from E to F. But when we have solved the numerical, we are finding the current is direction, true direction or actual direction is like that, this one. And the value of the current will be 48.3 ampere. Clear? Similarly, if we are talking about next one, so we are finding that if I'm going for IA minus 140, that's for 61.7 minus 140, again, we are getting minus value. So ultimately the current will be in this direction like that. And the value will be equal to 78.3 ampere. So you can see at E point, current are summing up. Means the current is coming from A to C in this direction, C to D in this direction, and D to E in this direction. But with the help of numerical solution, we are getting that the current from B to F is going in this direction and F to E in this direction. So you can see at this point, the direction is meeting, that is called summing point of both current. So that's why this is called potential at minimum point. Clear? Got it? Are you getting my point? Slow. Why E is minimum potential point? Why E is called as minimum potential point? Have you got my concept here? That why we have called E as a minimum potential point? Because at E point, we are getting sum up of both directional current. Clear? Okay, so that's why just we are applying that potential already question. We have find that what is the potential, or we can say point of minimum potential we have found. E is the point. E is the point of minimum potential. Clear? Point of minimum potential. So that's why if I'm finding the voltage VE, you can find very well what is the VE, of course. V, that is called, this time I'm making clear this one first of all. Now VE, we have to find voltage at this point. So we can do two things. We can do VA minus IA into RAC minus ICD into RCD minus IDE into RDE. Number one. Number two, we can do BB minus IFB into RFB and IFE into RFE. Hopefully you're getting my point. We can find the potential at this point also and this point also. If you are finding from this point, so of course 220 minus 220 minus drop of all three sections. First in AC section, then plus CD section, then plus DE section. The first method. Or we can find 220 minus drop of FV section. Clear? FV can say, BF we can call, or EF or FE section. So in both answers must be equal. If you are not getting equal answer, it means your calculation is wrong. So this is the method to check your answer. Clear? Are you getting my point? So just we have applied the first one, B minus BA minus drop of all three sections. Clear? Simple I into R. So already I found I that you have already have said, and the voltage will be E point 215.69. So is there any doubt in this numerical? Then you can ask. Any doubt is there? Aslo and Nesro, I'm not getting any response from your side. We have completed the numerical, totally numerical we have completed, but still I'm not getting any response. Okay, done. So second numerical I'm giving to you, okay, that you have to solve by self, of course. Now, solve this numerical Aslo, and this is actually DC, not DSC, it's DC. Clear? And give me the answer fast. Solve this numerical and give me answer. Take your time. I'm giving you 5 minutes now. First of all, draw the single line diagram that already I have said. That single line diagram you have to make. Now you can see we have given different voltage. First I have given at 230 volt. Clear? And at B I have given 235 volts. So you can see the change in voltage. So first I am giving here 230 volt. At B point I am giving 235 volt. Clear? The total length that you can see, this is 200 meter. Okay. And the tapping point you can see, this is 25 meter, 25 ampere at 50 meter from A. So I'm taking second color to them just to represent. That's your 50 meter from A. So this is your A point, of course. So 50 meter, I'm taking this point as C point because this is already A and B I have taken. So this is your 50 meter. 75 meter from A. So 75 minus 50, that means 25 meter. We are taking the second point that is called D. 100 meters, so 100 minus 75, again 25 meter. That is called point E. And 150, so of course 50 meter. That point F. And what is the remaining length that you can understand? 50 plus 25 plus 25, 100 plus 150, so that is your remaining 50 meter. Clear? The current they have already given. It's 25 ampere. It's 50 ampere. It's 30 ampere and 40 ampere. So first of all, the diagram have completed. That's your AC section. AC, it's CD, it's DE, and that's your EF section. Clear? So just I'm doing this one now. Already I've written this one above. You can see. Okay. Now just tell me at which direction we have to consider for current. Should I take the current from here or here? Just tell me from which point we have to start flow of current. Either A or B, and why? Again means what you want to ask actually. You can unmute yourself as slow. Unmute means what you are asking. My question is that current question. Okay, question. My question is that if I'm assuming the current, because already I solved one numerical. Just you have seen we have solved one numerical, but the thing is that in this numerical we have found something different. In the last one, we are feeding the equal voltage from both ends. Clear? So at that time, at which point we are feeding the current, that doesn't matter. But if we are having different voltage, so at which point we have to take initiation of current, that I'm asking, either A or B. Means we have to assume the current direction of flow current from A to B or B to A, that I'm asking. Okay, B. Good. Okay. So suppose I'm starting from B point, that I'm starting IB. Clear? Suppose I'm starting IB. So this is the current in section of B to F. Now, what is the current in FE? If I'm saying IBF equal to IB, what is the current in IFE section? Tell me, because already you can see this is the current I've given at each point. So what current, which amount of current will be flowing through F to B? If I'm saying I'm initiating the current B to F, that is IB, then E to F, which amount is going to current? Which amount of begins? What will be the value of current in this section IEF? I'm waiting for the replies. Okay. As you are getting my question. IB plus 40. Okay. If I'm flowing a current from here, if this is the current flowing IV, okay, and if I'm taking 40 ampere here, so what is the current in this branch? IB plus 40. What will the current here? It's your I1 is coming, incoming current. I2 I'm just tapping. That's I'm asking. So IB minus 40. Okay. And in next section, you can see I'm tapping 30 ampere. So what is the current I'm giving? That of course IB minus 70. IB minus 70. Similarly, here I will be minus 40. Here I will be minus 70. Here I will be minus 120. And here I will be IB minus 145. Clear? Now the resistance per kilometer of one conductor they have given. You can see 0.3 ohm resistance for 1 kilometer they have given. Clear? So this was your finding the current equation. Now how can you find resistance? So resistance they have given 0.3 ohm per conductor. So first of all, this is two-wire system. So for if I'm talking about this section, that is called, if I'm talking about the AC section, A to C section, then already I have said A to C section, we are having distance of 50 meter. Clear? So 2 into 0.3 into, because this is for kilometer, 1 kilometer. So we have to convert this 50 meter into kilometer. So divide by 1000. So we are getting my answer 0.03 ohm. That's your RAC. Clear? Similarly, if I'm finding RCD, because this is your C point, this is your D point, it's your E point, it's your F point that I'm tapping. Clear? So RCD, and that's your A point feeding. So RAC we have found. Now what is RCD? In RCD we have said that the distance will be 25 meters. So half of that. So what is the answer? 0.015 ohm. Clear? Again 25. So what is RD? Again the same answer. So first I have found the equations. Clear? Now the most important part is that we have to find, whenever we are finding the, because already you have assumed the current from B. Up current direction ऐसा था, B से A. You have assumed the current from B to A. So if I am finding the equation, so what is the VA? This will be BB minus all voltage drop. All voltage drop means 230 equal to 235 minus all voltage drop. Clear? Now just give me the value of IB. Solve the equation and give me the answer. And the persons who are giving the answer, I will put attendance only for those persons. Okay. So as low, keep in mind. Without, if there is any doubt, you can ask me. And if you are not giving me answer IB, then I will not put any attendance. Keep in mind. Okay. So solve, take your time and give me the answer of IB. Then I will cross verify your answer. Already have solved, don't worry. Because already just I have done the same similar numerical. What I've changed, we have changed only voltage. Nothing we have changed. Similar numerical we have done just now. So we have said that how can you make the equations, that already you have given the answer IB minus 40. Similarly, find the current of each section. The distance already I have told that how can you find the resistance of each section. Clear? Then after finding the resistance of each section, current of each section, then find voltage drop of each section, then apply this equation. BA equal to BB minus summation of all voltage drop, sum of all voltage drop. Clear? Then give me the equation of, give me the answer of IB. Nasro, if you are not giving any reply, I will not mark present to you. Keep in mind. Nasro, you are listening me? So first of all, give me the value of IB. If you are able to find the value of IB, then we can find current in each section, and then we can find minimum voltage and the point at which it occurs. Okay, Astro. So just already time is going now. So solve this numerical and just take the screenshot of this numerical. Okay, I'm giving this, closing the session now. So just take a screenshot of this numerical. This is your DC again, I'm saying, and solve this numerical and send it to me. You have to send solution of this problem to me on my WhatsApp number. Okay, whenever you are sending solution of this problem, only and only that condition I will put your attendance today. Clear? Keep in mind, Aslo and Nastro, both of you. But if you have any doubt, you can ask me now. But if you don't have any doubt, you have to solve this numerical. Clear? Nastro, you can send on my in the Telegram. Don't worry. Okay, on Telegram, you can send it to me. And if you don't have anything else, you have already my email ID. I'm writing in the chat box. So just copy that email ID. You can send on my email ID also. Clear? But if you're not sending the solution of this numerical, I'm not going to put any attendance today, because just we have solved the similar numerical before. Okay. So I'm closing my session. So today I've discussed about some numerical problem of DC distribution, feeding from one end and feeding from both end. Clear? In next lecture, I will discuss about numerical problem on ring system or interconnect system. Okay. So just I'm ending the session. You can take a screenshot of this problem you have to solve, and you have to send it the solution on my email ID, on my WhatsApp or my Telegram. Wherever you want to send, you can send it to me. Okay. So just I'm concluding the session. Thanks to all of you. I'm ending the meeting now.